Okay, so let us proceed dun sa problems 4 to 7 ng FLUMAC nyo. So this is for problem number 4. Basahin ko lang yung question. A vacuum pump is used to drain a flooded mine shaft. So very familiar to kung kayo naging student ko na ng fluid machinery. At 70 degrees Fahrenheit of water. The pump pressure of water at this temperature is 7.7 psi and its specific volume is 0.017 cubic foot per pound. The pump is incapable of lifting the water higher than 17 feet. What is the atmospheric pressure in kilogram force per cm squared? O, take note. Recall natin yung mga conversion of unit. So, 1 atmosphere, okay, this is equal to ilan? Kapag SI, this is 101.325 kPa. This is equal to 760 millimeter Hg equal to 760 torricelis or tor equal to 10.33 meters of H2O equal to 29.92 inches of Hg equal to ilan? 14.7 PSI. Hindi na natin kailangan elaborate pa iba. And, ito na yung huli, 1.033 or 32 kilogram force per cm squared. Ayan. So, ito na yun sa pressure conversions. So, ito, di ba? Simple Bernoulli lang naman to eh. Okay? So, you have here a pressure at suction divided by yung gamma ng water plus velocity at suction is squared over 2g plus, okay? Plus yung Z at suction equal to yung PD sa discharge plus VD squared over 2G plus ZD. Ngayon, di ba yung head dun sa suction side and then yung head dun sa discharge side is equal. May or magkakaroon sila equilibrium. Na wala naman ditong binigay sa yung size ng piping, wala rin binigay sa yung amount ng tubig or the flow ng tubig na kailangan mo. So, we can cancel this out. Okay? Cancel this out. Ano pong hinahanap natin dito, sir? Ay, hindi pala. Mali pala ako ng ano. Ito. Sir, ano pong hinahanap natin dito? Actually, ang hinahanap natin dito is the atmospheric pressure. Ibig sabihin, yung patapon na nung inyong mine shaft. Ibig sabihin, sa loob ng mine shaft, itatapon niya papalabas sa discharge. Okay? So, the discharge side ang hinahanap natin. Okay? So, ito ang hinahanap po natin. So, i-arrange natin. Diba? Take note that we now have yung delta Z, yung change in elevation, which is 17 meters. Oh, set aside na natin to. Okay? This will become now PD over ito equal to PS over ito plus delta Z. Okay, hinahanap natin si PD. So, i-multiply natin both sides ng 1 over gamma. O, recall natin. Recall natin ha. That gamma is equal to density times gravity. Pero, ang density natin, di ba equal yan sa 1 over the specific volume? O, di ba ang binigay dyan is specific volume? Ito. O, ngayon, pwede nating solve. So, PD now is equal to PS over gamma plus delta Z times gravity over specific volume. Or, or, ito naman kasi pwede yang, ito dito yan, no, equal to B raised to negative 1 times G. Pwede na yun. PD is equal to, okay? Binigay dyan sa suction, sinabi mo bang vacuum? Hindi. So, 7.7 pound per inch squared. Pag nakakita kayo niyan, lagi nyo i-multiply ng 144 inch squared per feet squared. Divide by, ito, diba equal yan kapag English sa water. Pero, hindi sa'yo binigay na standard ng water kasi binigay sa'yo yung specific volume. So, that is, pwede yan, okay? Kahit hindi na to, okay? 1 over 0.0117 0.017 feet cube per pound. Sir, bakit ganun? Tignan mo 'di ba sabi ko sa inyo, kapag dating ng English, ito ay equal dito. Pareho lang silang ng unit. Oh, tignan mo yung unit nito, pound per feet cube. Anong unit nito? Pound per feet cube. English units. English units only. Okay? Oh, tapos i-multiply mo nung ito. Okay, multiplied to 1 pound per 0.017 feet cube per pound. Okay, naka-feet cube per pound dapat dito. Okay, ang lalabas dito is in squared pound per feet squared. Pwede na yun. Pound per feet squared. Kasi maka-cancel to eh. Okay, pound per feet squared. In squared. Actually, kahit di ka na mag-multiply nito eh. Okay? Kahit di ka na mag-multiply nito kung 144 in squared. As is na yan. Okay? So, 7.7 pound per inch squared. Kasi maka-cancel na ito. Ayan o, cancel natin. Cancel natin. Unit na natira, pound per inch squared. Ano ba yun nandito ang direkta? O, bilugan mo, pound per inch squared. Tapos, kilogram per cm squared ang hinahanap eh. Ayan o. O di, 14.7 pound per inch squared times 1.033 pounds. Oh, may nakalimutan pala ako yung delta Z. Okay, urong natin sila. Nakalimutan ko pala yun. So, pwede yan. I-correct natin PS. Okay. So, that is 7.7 pound per inch squared. Hindi ako nakatingin eh. Times 144 inch squared per feet squared. Divide by 1 over 1 pound 1 pound per feet squared. Yun, 0.017 feet, feet cube pala. Feet cube. Plus 17 feet. Ang lalabas dito, feet din eh. Kaya kinonvert talaga. Multiply natin ng ito. So, this is 0.017 feet cube per pound negative 1 times Sir, ba't -1? Inverse eh. Times. Ang lalabas dito, feet. Okay, feet squared. I-multiply natin ng 1 feet squared per 144 inch squared. And then, check natin yung units na matitira. Inch squared. Tapos dito, feet. Ang natira, feet sa loob. Ito, babaliktarin mo to. Inverse niyan. So, feet over feet squared. Bale, ang natira is feet squared yung nasa baba. Okay, cancel na to. Tapos yung pound, nasa taas na yan. Okay, itanaas mo tong pound. Inch squared. Pound per inch squared na natira. Okay, multiply natin ng 14.7 PSI or pound per inch squared. Ito naman is 1.033 kilogram per cm squared. Okay, cancel to. Ang natira is kilogram per cm squared. So, 7.7 times 144 divide by 0.017 raised to -1 times, kulang pa, plus 17. Lagi ko nakakaligtaan. Times 0.017 raised to -1 times, ito, nasa baba. O di 144 raised to -1 times 1.033 divided by 14.7. The answer will be 1 point. The pressure at discharge is equal to 1.0291 kilogram force per cm squared. Okay, that is for problem number 4. How about problem number 5? The piston displacement of an air compressor. So, air compressor na tayo. Okay? For the entire discussion ng air compressor, meron ako niyang available sa aking fluid machinery discussions. Okay? So, ang gagawin ko na lang isolve to and pinpoint yung ano mga dapat yung tandaan. Meron siyang piston displacement na, so volume discharge ang binigay sa'yo. 1,200 gallons per minute. Okay? Sir, yung volume discharge, that is equal to the bore and stroke. Okay? The bore and stroke. Ano po ba pinag-uusapan natin sa bore and stroke? Kailangan mo yung length of the stroke multiplied to the area ng stroke. Okay? Cross-sectional area ng piston multiplied to the rotational speed of the machine multiplied to the number of cylinders kasi total volume na yun eh. Total volume ang inisinusupply niya. Okay? Multiplied to the number of acting. Usually kapag compressor na single acting lang yan. Okay? And then hindi, the factor single lang yan. Ang acting is depende. Okay? Depende yan. So langka. Tandaan nyo that VD is equal to langka. Now, how will you get the compressor power? Meron tayong iba't ibang uri ng compressor power dyan. Ngayon, kapag pinag-usapan natin if that is the maximum power, pag maximum power, that should be the constant temperature, isometric work. Okay? Yung work ng compressor, if maximum, that is the isothermal work. Kapag naman, actual work, okay, that is the polytropic work. How about yung minimum work? That is the isentropic work. Ayan. So, sir, saan mo ba makukuha yung mga isothermal work na yan? Polytropic work, isentropic work. Ito lang po yun. Okay. Yung work ng compressor mo kapag maximum, syempre, yung pag-uusapan mo dyan is the initial pressure, the volume. Hindi yan volume displaced ha. This is the volume supply. Okay? The available air. Okay? Available air. Yung volume discharge, yun yung sinupply niya. Ito naman yung air available. So, Ln ng P2 over P1. Or, di ba, this is isentropic, isothermal. Ibig sabihin, temperature is constant. O, PV over T equal to PV over T. This is 1, this is 2. Cancel ito, cancel yan. Ibig sabihin, inverse. Okay? This is P2, P1, B1, B2. So, inverse yan. Pwedeng P1, B1, Ln ng yung volumes, B1 over B2. Okay? The maximum volume, minimum volume. Yan. How about isentropic work? Or the actual? Hindi. Actual muna tayo, polytropic work. For the polytropic, syempre, ito, papalitan mo lang ng this is K. Okay? This is N. Nung substance. Okay. This is, pinag-usapan natin is polytropic N, P1, B1, over N minus 1, multiplied to P2 over P1, raised to N minus 1 over N, minus 1. Pwede na yan. Or, di ba ang PV pag PV, MRT, or ideal gas equation, PV is equal to MRT. So, this is also equal to N, R, N, M, R, T1 over N minus 1, P2 over P1, raised to N minus 1 over N minus 1. Oh, ito na yun. Pwede yan. This is only for single, okay, single staging, okay? How about naman yung isentropic? Oh, isentropic work ng iyong compressor. Palitan mo lang lahat ng N dyan ng K. O di K, P1, B1 over K minus 1. Sir, bakit po nagiging negative yung work ng compressor? Kasi nga, the work is done by the system. Taken out of the system. Okay? Ikaw yung gumawa ng work, hindi ikaw yung ginawa ng work. Kaya, pwedeng negative yung maging sagot dyan. P2 over P1 raised to K minus 1 over K minus 1. O, ganun din dito. Palitan mo lang ng K. K, M, R, T1. Ang daming formula pagdating na compressor. Kaya, ito yung pinakamadaling solve, compressor. Alamin mo lang kung ano yung air available, yung air supplied, okay? Yung volume discharge, okay? Yung pinagkaiba nun. Yan. So, this is for single staging. Okay? How about naman, sir, kapag may binabanggit dito, may binabanggit dito. How will you get the volume discharge? Okay. Paano natin makukuha yung volume discharge? Ito na, binibigay, oh. Commonly, sa problem, ang laging binibigay dyan is the volume discharge. Hindi niya binibigay yung V1. How will you get yung V1? Okay. Number 1, pwedeng nandito yan sa P. Nandito yan, oh. V1 is equal to MR T1 over P1. Dito mo kunin yan. Okay, number 1. Dito, paano mo i-solve si P1? Gamitin mo si PBMRT relationships. Number 2, dito mo kunin kapag binigyan ka ng volumetric efficiency. Pag binigyan ka ng volumetric efficiency, that is equal to V1 over VD. O, kunin mo dito si V1. So, V1 is equal to EV times VD. Where VD is given na sa taas, okay? Ito yung second equation. Or, kapag binigyan ka naman ng clearance, okay? Di ba EV is equal to V1 over VD. And, also, yan kasi is equal to 1 plus the clearance minus the clearance multiplied to P2 over P1 raised to 1 over N or 1 over K. Ito yung third equation. Pero mostly, ito lang yung dalawang ginagamitan mo niyan. How about naman, sir, check natin. How about kapag multiple staging ka na? Yun, doon na papasok yun. If you've got the multiple staging, okay, meron tayong general formula. So, pag multiple stage, the work of the compressor for multiple stage is equal to yung number of stages multiplied to N, P1, B1 over N minus 1. Multiplied to P2 over P1. Sundin niya, P2 over P1. Raised to N minus 1 over number of stages multiplied to N minus 1. Para hindi kayo malilito. Hindi nyo na isosolve yung pressure at discharge. Kapag given si P2 and P1, as is na yan, tapos na agad ang computation mo. Kapag double staging, dalawang stage, multiply mo lang ng 2. 2. Kapag naman multiple stage, kuwari 3, 4, 5, 6, and so on. So, multiply, palitan mo lang yung S dyan, nung number of stages. How about naman yung pressure of intercooler? The pressure of intercooler, okay, PX, okay? Hindi natin alam yan. Kung gaano karaming stages, ito yun. Yun yung sa radical mo. Yan yung index mo dyan. And then, P1. Erase mo ng I. Okay? Kung ilang intercoolers ka riyan. Minus P2. Hindi pala. Multiplied to P2. Multiplied to P2. Raised to yung number of stages minus yung intercooler. Number of intercoolers. Yan na. How about naman the heat that is taken out of the intercooler? The QX is equal to mass nung pumasok na coolant dun sa iyong intercooler, yung CP nun, okay, temperature niya, Tx minus T1. Okay? Ito lang yun. Meron pa ba iba? Meron pa sabing iba? Wala na sir. Yan na lang. So let us solve yung number 5. Binigay ko na sa inyo yung summary ha. Huwag nyo kalimutan yan. So, compute the operating speed. Its bore and stroke, yan, are 12 inches and 1.2 feet, respectively. Ang hinahanap is N. So, yan. So, you have BD is equal to L, A, N, C, K, at A. Number of acting is 1. Number of cylinder is 1. Tapos yung K is 1 na rin. Okay? Ang hinahanap mo na lang dyan is what? The rotations, N. So, VD is equal to L, area nung piston, natural, circular yan. Okay, cylindrical, pi over 4, D squared, times N. O, 1, 1, 1, 1 na lang yan. So, hinanap natin si N. Therefore, N is equal to 4 times VD over pi L D squared. 4 times 1,200 gallon in every minute. Okay. Pi, yung L is, the length is bore and stroke. The length is 1.2 feet. 1.2 feet. Tapos nakalagay dito yung bore mo is 12 inches. O, that is equal to 1 feet din. 1 feet. Square natin. Okay? And then, yung D squared. Yan na yun. D squared ln. Okay, feet cube. Convert na lang natin to into feet cube. Ilang gallon? So, 1 cubic foot, 7.481 gallon. Cancel all the same units. Feet, feet, yung feet cube, gallon, gallon. Ang natira is minute. O, di ba revolution is non-unit? O, yun ang sagot. So, that is 4 times 1, 2. 7.481 shift pi times 1.2. The answer is 170.19. 170.1964 RPM. That is for problem number 5. Problem number 6. Compute the discharge velocity of air in meter per second if a turbo compressor is used to compress 14.7 pounds per square per second of air. Ano ba? Of air in an initial pressure of 14.7 psi. So, P1. Yan yun. To a discharge pressure of 147 PD, P2. Inlet and outlet temperature is 74.1 degrees Fahrenheit and 741 degrees Fahrenheit, respectively. Use an inlet pipe diameter of 14.7 inches and outlet pipe diameter of 7.41 inches. Anong problema rito? Okay. Okay. Kahit naman magbigay yan dito ng iba't ibang state, 'di ba sabi ko that the flow rate is always constant. Tama, 'di ba? So, therefore, Q is equal to area times velocity. Dito natin makukuha yung velocity. Meron ba tayong Q? Wala. Meron tayong A? Yes, binigay niyo yung sizes. Okay? Gamitin na lang natin lahat ng nasa 1. Problema mo, binigyan ka ng pressure, binigyan ka ng volume, binigyan ka ng mass. Tingin ko meron. Ayun, meron. Tapos R, that is constant kapag air. Temperature at 1. O, di 1 lahat yan. Anong wala ka dyan? Di ba ito equal to sa volume flow rate? Ayun yun, no? O. Di ba? I-reform natin. Volume flow rate is equal to Q. O. Q is equal to M R T1 over P. Diba? Tapos, pwede natin tong ilipat dyan. Equate na natin. M R T1 over P1 equal to the area area nung inlet-outlet pipe. So, piping lang naman yan. Okay, cross-sectional area, pi over 4 d squared times. Okay, balik tayo dito, velocity. Ang hinahanap natin is velocity. O, lipat ko na lahat. Velocity is equal to 4 m r t1 over pi p1 d squared. O, di meron tayong bagong formula na create. So, we can now solve for the value of velocity. Lahat gagamitin ko initial kung initial, final kung final. So, the velocity is equal to 4. Yung mass niya is 14.7 pound per second times, ano ba ang R ng air? O, recall natin, the R of air is 0.28708 kilojoule per kilogram degree Kelvin. Kapag SI, pag English, that is 53.34 pound foot per pound degree Rankine. So, 53.34 pound foot per pound degree Rankine. Tapos, the temperature. Initial lang kukunin ko. Okay? O, kung gusto nyo, naka-Rankine na agad. O, yung pangalawa na agad, 741 degrees. Degrees Rankine. Over pi. Tapos, yung pressure ng pangalawa. Ano ba yung second pressure dyan? That is 147 pound per inch squared. Diba sabi ko, lagi mo multiply ng 144 inch squared per feet squared. O, meron ka ng pressure. Yung D na lang. Ano ba yung D dyan? Ang ginamit ko is 2. O, si 7.41 inches. Op, gawin ko na agad feet. 7.41 divide by 12 para maging feet squared. Okay, cancel all the same units. Ang lalabas dyan is feet per second. Okay? But feet per second. So, meron kang cancel natin si pound, pound, inch squared. Okay? Feet squared. So, feet, Rankine. Feet per second ang lumabas. O, kailangan natin ng conversion of unit. 3.28 feet 1 meter. Cancel natin si feet. Ang lumabas na is seconds tsaka meters. Yan. We can now solve for number 6. 4 times 147, 14.7 pala yan, no? Times 53.34 times 741 divide by shift pi times 147 times 144 times 7 over 12, 7.41 times 12, no? Divide by 12. 12 raised to 2 times 3.28. The answer will be 27.94. The velocity of air is 27.9429 meters in every second. Very basic. Okay, that is for problem number 6. How about problem number 7? Calculate the power required to drive the first stage of a single acting two-stage compressor that delivers air at 25.5 bars. The air enters, so that is the air supplied to the system, 25.5, so B1 yan. 25.5 cubic meter per minute with a temperature of 25.5 degrees Celsius and ang pressure daw niya is, so ito yung pressure 1. This is pressure 2. Delivers air eh. 1.0255 bar respectively. The compressor is designed for minimum work. Oh, that is, ano yan? That is minimum work. I think that is polytropic. Polytropic ba? Ayun, polytropic kasi iba eh. Minimum work. Kung ano, minimum work. Actual work pala is isentropic. Oh, polytropic. With complete intercooling using, yung N niya is 1.255. So, anong sinosolve natin dyan? Two-stage. Kaya lang, first stage ang sinosolve. Tama ba? To drive the first stage. Okay. So, work of the compressor, two-stage yan. Ito na lang is N, P1, B1, over N minus 1. Multiplied to P2 over P1. Huwag mo nang pahirapan sarili mo. N minus 1 over S N minus 1. Ito na yung general formula for multiple stage. So, the work of the compressor is equal to S, two-stage, times N, 1.255, times P1, that is 1.0255 bars. 1.0255 bar times 100 kPa. Kilonewton per meter squared na lang. Divide by 1 bar. Multiplied to the volume of air. What is the volume of air? Para maging seconds, naka-minute yan. So, that is 25.5. 25.5 cubic meter. Divide natin ng 60 para maging seconds. Okay. N minus 1, so 1.255 minus 1. Multiplied 2. Huwag nyo na cancel yung, huwag nyo na ilagay unit, maka-cancel na yon. So, 25.5 divide by 1.0255 raised to 1.255 minus 1 over 2 times 1.255 minus 1. Okay. Cancel natin yung same units. Okay. Ano ba ang hinahanap dyan? HP. Cancel muna natin. Si bar, meters, may matirang 1 kilonewton, meter in every second, that is kilojoule per second, that is kilowatts. Kunin natin yung unit niya, yung magka-cancel sa kanya. So, multiply ko ng buo. Ng 1 HP, 0.746 kilowatts. Cancel natin si kilowatts. Okay? The answer will be 2 times 1.255 times 1.0255 times 100 times 25.5 divided by 60. Okay. Okay, 1.255 minus 1. Yun, 25.5. 1.0255 raised to 0.255, minus ko na agad yung 1, divide by 2 times 1.255. Then, all in all, minus 1. Kasya, di ba? 165, kaya lang, hindi ko pa dinidivide yan, okay? Hindi ko pa dinidivide ng 0.746. Sir, 222. 222. That is equal to 222.015 HP. Sir, sa dalawang stage 2 That is the power that is consumed on 2 stages. Ang hinahanap dyan, the power that is enough to drive the first stage. Oh, for the power that is enough to the first stage and the system is ideal, okay? Oh, yung work ng first stage plus work ng second stage. O ibig sabihin, itong dalawang to equal to one another. Therefore, okay, yung work to drive the first stage is equal to yung work ng compressor total divide by 2. Oh, the answer is 1111. 111.01 HP. Okay? That is the power to drive the first stage. That is for problem number 7. Let us take a 5-minute break.